After our online session on the 4th of March 2020, I did what any decent teacher does after a class. I started thinking about food. But when I got to the entrance of our school, I found something more interesting than food. Electrical cables! At the moment, the school swimming pool is undergoing a huge refurbishment. When I walked past the entrance lobby and entrance to the swimming pool, I saw this. As part of the refurbishment, the old wiring system is being updated. These wires are the main ones they were using. From the left you can see the brown live wire, the yellow and green earth wire, and the blue neutral wire. And then you can see them all again! Jumbo size! The ones on the left are for normal wires from appliances like air conditioners to the plugs. And the larger ones are for the mains wires inside the wall. Here you can see the thicker cord neutral cable on the right and the thinner cord one on the left. The next really exciting thing I'm going to show you is a switch. Yeah, but I'm afraid it's just so awesome, I can only show it in its box. This switch is literally just a way of connecting and disconnecting a complete path of electricity for the entire swimming pool. But look at the label in the top right. First you can see the IP rating, which shows what protection the case offers. In our case, we're interested in IP54, which is highlighted here, and means the case offers limited protection from dust and water splashes from any direction. Back to the case, we can see a circuit diagram for a switch. Go for someone playing golf or something? Now look at the numbers. UE, IE, and UIMP. Well, you can guess them from the units, what they basically are. UE is the rated voltage, which means the switch box could technically handle a 415 volt alternating voltage, which is alternating at a frequency of 50 or 60 hertz. That means the current is being driven one way and then the opposite way 50 or 60 times a second. The IE is the rated current, which here is 100 amperes, or 63 if you want to run a voltage of 690 volts through the switch instead. In UIMP, the U means voltage again, but the value is huge. 8 kilovolts, meaning 8,000 volts. It's hard to keep voltage very stable when things are being turned on and off in these circuits and in the mains power lines going to this switch. So it can happen that for very short times there are jumps in the voltage. UIMP is the impulse voltage, which means this box can withstand a voltage spike up to 8,000 volts. If the voltage goes beyond this, then the current may be driven in unpredictable ways, causing overheating and electrical fires, for example. I found an electrician who then showed me where the electricity for the pool comes from. I traced them all back to the room at the bottom of the SIP building. On the other side of that room, I found this. Dangerous. So it seems to be around here that all the school's electronics are focused. This and our online class discussing how earth wires are earthed locally and neutral wires are earthed at the power station got me thinking. So I went looking for earth wires. But that's not the end of the story. When I finished all of this, I left school and I went around the back of the SIP building. When I did that, I saw this. And just to the right of St. Paul's Convent School substation, I saw a thick wire going into the ground. Here. Yes. Is this the earth wire for the school?